All right, welcome back, Algebra 2. So on to the next example. Example 4 says, suppose x is greater than 0 and x cannot be 1. Rewrite log x to the 7th power in terms of just log x. So we have log x to the 7th power. So we have our power of a product, or power of a log property here. So remember, this means we can take this guy and pull it all the way out front and say that it's equivalent to 7 times log of x. Okay, so really these are the same thing. If you have log of anything to the exponent, you can pull that exponent out front and say multiplication. So that's actually all we can do with this guy. So we've written it in terms of regular log x, and we just pulled that 7 out front. These two things are equivalent. Next example. Example 5 says solve for p. We have log of p equaling 3 log of 5 plus log of 2. So essentially we want to solve for p. So I'm going to rewrite this whole equation. So log p equals 3 log 5 plus log 2. Okay, so essentially we want to get this side to be one logarithm. So we're going to use our powers of logarithms here to kind of reduce this, I guess we could say. So, and as I'm doing that, I'm going to go ahead and write out each step that I do and what property I use. So I'm going to address this first because I have this 3 out in front. So remember, when we have 3 times this log of 5, we can rewrite that as log of 5 to the 3rd power. And that was basically our product property backwards. So, oops, sorry. I'm going to go ahead and just write the rest of this. I haven't dealt with this log of 2 yet. So this came from a power property of logs. Whoops. Power property of logs. Okay. We just used it backwards, and that's okay. We can do that. All right, so I've condensed this guy a little bit. And now I have these 2 logs, and they have the same base. Remember, their base, if they don't have one, is 10. And I can add them together. And when I do that, though, I'm going to say log of p equals, when I write them as a single log, they become log of 5 to the 3rd power times 2. So when we add 2 logs together and we write them as a single one, it becomes a multiplication. So this is our product property of logs here. Product property of logs. Okay. So now I've written this as a single log, and then I could just figure out what 5 to the 3rd times 2 is. So log of p equals log of, well, 5 to the 3rd is 125. 125 times 2 is 250. And since these are both log base 10, really, we know, and just like with exponent, if you have the exact same thing on the left as you do on the right, you can just get rid of them. So therefore, all we have left over is p being 250. Okay, so that's actually our answer. We've just solved for p, it's 250. So we've used our power property of logs and our product property of logs, and then said, okay, we got 2 equivalent logs. Well, then just say their p would be 250. So easy as that. Okay, here's a couple here for you to try yourself. So it says simplify and tell what property you use. So here you have 1, which is log base 2 of 25 plus log base 2 of 7. So go ahead and simplify that and tell what property you've used. So make sure that you do that as well. So two answers here. 2 should be log base 5 of 40 minus log base 5 of 8. Again, simplify and tell what property you used. And then down here, I want you to go ahead and see if you can solve for x here. So give those your best shot and bring me your answers tomorrow. See you mañana.